Oh, whoops. Is this thing on? Oh, my bad. Oh, hi class. Alright, let's actually get to work. So today we're going to talk about real numbers and the number line. So we're going to kind of go more in depth into what we did last week when we talked about the real number system. So before we do, I want to talk about a few key terms again like we did yesterday. And let's make sure you guys can see this. So I already kind of put a couple key terms written down already, my kind of sloppy handwriting. Let's see if I can focus in. I may have to read out loud to you guys. Let's see if I can get the autofocus. Oh, perfect. And I'm going to read you the definition. Let's talk about it. And I'm going to explain to you guys. So the first one, I'm going to read you the definition, what it says. But honestly, I'm not the biggest fan of it, so I'm going to explain to you. And then I'm actually going to ask you guys maybe tomorrow, see if you guys can come up with a better definition. Because the one I have is the textbook definition, but the best one. So I'm going to begin by talking about a square root. So you guys are pretty familiar in terms of what a square root is. So the definition I have written down is a number A is a square root of a number B if A squared equals B. So what does that mean? So for example, one of my favorite numbers is 7. Lucky 7. So we know that, for example, 7 squared is 49, right? Because it's 7 times 7. So because 7 squared, so a number squared is 49, that means 7 is the square root of 49. And it works for a lot of numbers, which you guys are probably aware of. So for example, we know that, we can do it another one. Like we can say 5 squared is equal to 25. So we can say 5 is the square root of 25. Now, in terms of writing it, there's a mathematical symbol that means square root, as you guys are probably aware of. And the mathematical symbol for square root is this kind of strange symbol like that. Kind of like that little bit of a hook and that. And so that symbol is called a radical. So the symbol for non-negative square root. So the answer is always going to be a positive number. So the square root of 25 is just 5. Alright, so this symbol is called a radical. And whatever number or expression is inside is called a radicand. So the expression under the radical symbol is a radicand. So for the first problem over here, we know if I put over here, the square root of 49 is 7. So the same way I wrote over here as a sentence, 7 is the square root of 49, I would write it this way. It's the mathematical way of saying it. The square root of 49 is 7, in which the radicand is 49 and the square root is 7. Alright, so let's give a quick practice now. So now for question 1, I'm going to ask you guys to simplify these two expressions. So if you know how to do it, quickly hit pause, try to do these two questions before I go over it. Alright, so if you've done it, let's see if you got it right. For the first one, it's asking for the square root of 81. So I'm looking for what number times itself, right? Look at the definition. What number squared gives me 81? And it has to be a positive number. So in that case, the answer is going to be 9. Because 9 times 9 is 81. Now this one's very complicated for some kids, so it can be confusing. And sometimes what it helps to do is to split it up And so we have the whole, this fraction under the square root. Sometimes it's helpful to look at as the square root of the numerator and the square root of the denominator separately. If you do that, it becomes a whole lot easier. And so the square root of 9 is 3, because 3 times 3 is 9. And the square root of 16 is 4, because 4 times 4 is 16. And it works out, because 3/4 times 3/4 is 9/16. And it works. So now let's move on to something a little bit more challenging. So for this question, number 2, first I'm going to ask you guys to do is, I'm going to ask you guys to change something, just to make our lives a little bit easier, is I've changed one of the numbers. So right here, I think the number was 386. Just to make our lives a little easier, can you change that number to a 90? Let's change that number to a 90 to make our lives a little easier. Alright, so if you've done that, the question reads, lobster eyes are made of tiny square regions. Under a microscope, the surface of the eye looks like a graph paper. It's actually true. A scientist measures the area of one of the squares to be 90 square microns, which is like super duper small, can't even see it. What is the approximate side length of the square to the nearest micron? So what's this question asking for? Well, first off, it's asking for approximate. And that's the key word. Approximate means I don't want the exact answer. I want to know where about the answer is going to be. Alright? So in the previous questions, I want the exact answer. But in this case, I want about. And so why is an approximate answer what I want? Well, because right now, 90 isn't a number I know the square root of. Right? Like, I know that, like, for example, this one, 81 was easy because 9 times 9 is 81. But there's no number, a nice whole number, that when I multiply it by itself will give me 90. Right? So that's why they want an approximate answer. They want to know where is it going to be about. So what I do, I think of what numbers do I know the square root of that's close to it for method 1. And so I'm looking at it, well, I know that, I know that we know that 90 is like, I'm going to put 90 in the middle. I know that 100 is 10 squared, right? And then we know that 9 squared is 81, right? So the square root of 81 is 9, and the square root of 100 is 10. So this is 9 and 10. So the square root of 90 is going to be between 9 and 10. It's going to be some sort of decimal. So I don't know what's going to be, but it's going to be between 9 and 10. Because the square root of 81 equals 9, and the square root of 100 equals 10. And 90 is between 81. 90 is between 81 and 100. So that's method 1. This is kind of an old school way before, I had to do in my head a lot. So I thought of like, what numbers do I know how to find the square root of? But the number that I don't know how to square root of is in between. Now method 2 is the way I think you guys are going to prefer. And that's going to be using a graphing calculator. So what I'm going to do is I'm going to simply type it in on the calculator. So if you look right here, you guys can see tomorrow is right here. You see in blue? That's the square root symbol. So what I'm going to do is I'm going to get anything in blue, I'm going to press second, square root, and I'm going to type in the number. And I'm going to then press enter. So that's a long number, a lot of numbers to write down. Now this is, as you know, going to be an irrational number. It's going to keep on going forever. So I'm going to, for point today, I'm going to round to the nearest hundredths place. So that's approximating. So 9.4 9 if I round. So this one, 9.49, and so I rounded to the hundredths place. Using a calculator. And so this is how we can estimate it if I can't find the square root easily. Hope I'm not going too fast. Alright, so for the next page is, because we did it last week, I'm not going to spend too much time doing it. I'm going to keep the video nice and short. I'm going to ask you guys to, by yourself, kind of just quickly review the different types of number systems. We talked about it last type. So this page kind of just reviews the numbers we talked about. So you guys remember that cute little video we talked about last time? I think I posted under chapters 0.1 and 0.2, the song that talked about natural numbers, whole numbers, integers, rational, and then irrational, right? So take a look at these type of numbers, and as a quick concept to show you, I have a little chart for you guys. So here we talked about kind of different sets of numbers. So like this was the simple numbers, the ones you first start learning about maybe as a kid, counting from like 1, 2, 3, 4s, and then get more complicated. Then you added whole numbers, which is 0. Then you added negative numbers. Now it can be cold outside, right? I can owe someone money. Then I added rational numbers because I can have fractions. Then I added irrational numbers, those square roots, those pi, right? Numbers that keep on going forever, but don't terminate, don't repeat. And then all those numbers, that every number you can possibly imagine is always a type of real number. So take a look, make sure that you are familiar with these types of numbers, and you can move on from that. So I'm not going to spend a lot of time going over it because we went over it last week. So before we go over the last part of today's lesson, is I want to cover one more term that I already covered here before. I want to talk about an inequality. Now, an inequality is any mathematical sentence that compares the value of two expressions using an inequality symbol. So, what is an inequality symbol? So, an inequality symbol compares, once again, two things. So I can say, so instead of saying something so that two things are equal, which is an equal symbol, I can say things are greater. I can say things are less than something. So that's just one symbol. I can say things are greater and equal. Or I can say things are less than or equal. So those are the four symbols you're going to see. So we have greater, we have less than, we have greater or equal, and we have less or equal. Those are the four symbols you're going to see. So these are the inequalities. So I can say things are comparing them. So for example, we can say if I have the numbers 3 and 4, obviously 4 is bigger, so I can say this way: 3 is less than 4. Notice the bigger side is facing the bigger number. If I go the other way around, 4 is greater than 3. Once again, the bigger side is facing the bigger number. Alright. So, it's quick practice. Let's review everything we've done so far. We're doing the last 3 questions. Once again, if you feel up to it, please pause the video, answer these questions before I go over it kind of quickly. So for question 1, for question 3, it's classifying as real numbers, meaning put into each of these two numbers into all the proper subsets. So the first one, 15. Well, first off, I tend to go from simplistic all the way to more complicated. So first off, this is 15 is a natural number because I can count, right? 1, 2, 3, 4, and up. Then, well, it's also a whole number because it's greater than 0, right? It's also an integer, a positive and negative whole number, right? Then it's also a rational number, because I can write it as a fraction, right? 15 over 1. We discussed that last week. All right? And because it's a rational number, because it's any type of number, it's also going to be a real number. And if you look at the chart, which is right over here, you can see, once again, 15 would be placed right here. And once it's in this box, it's going to be part of all of these. Right here. Right? Once it's here, it's going to be part of all these numbers. Alright. Next one. This one's a little bit more challenging. This one has a negative number and has all these decimals. So off the back, it's not a natural number, right? It's not an easy counting number. It's not a whole number, right? Well, an integer, it is negative, but integers are all negative and positive whole numbers, so it's already not these three. Now, the number does end. So because it's an ending decimal, it means that somehow I can write it as a fraction if I wanted to. It wouldn't be a nice fraction, but it would be a fraction, which means I can write it as, it's going to be a rational number. And any rational number, all numbers that we learned so far, is going to be a real number. So, just 2 categories for that one. Alright, so that one's going to fit right over here. Alright, and I'm going to header it up. So here it is. So what inequality compares to 2 numbers? So here we have 2 nasty decimals. So how do we compare them? I'm going to take my calculator, and the best way to compare them is to use a calculator. So I'm going to zoom up a bit. I'm going to take my calculator. I'm going to type in the square root of, whoops, gotta hit clear. Square root of 17. Hit enter. This gives me about 4.123. 1. And this one, this one's a little tougher. How do you do a mixed fraction? Sometimes this one means 4 plus 1/3, so 4 and a little more than a third. So I'm going to do 4. So I'm going to do 1/3 first. I'm going to add 4 to it. So this means 4.333. It's a lot of threes. I'm going to put a little bar on top of it. So that means the 3 keeps on going. So this one is, if I look at it, if I stop here, it's like $4.33. And this is $4.12. So this is the bigger number. So I'm going to draw an inequality so that the bigger side faces the bigger number. I'm going to say the square root of 17 is less than 4 1/3. Alright, last but not least, we have a multiple choice question. They want to order the numbers from least to greatest. So we have 1, 2, 3, 4, 5 numbers. So the first thing I got to do is I got to figure out, well, it's a multiple choice question. So I'm going to put the numbers from smallest to largest. So in order to do it with a lot of numbers, once again, it's probably easy to compare all the decimals. So I'm going to convert to decimals first. And then once I have that, it's probably easy to look. Well, if I'm looking carefully, I can see that 2 of them are negative, right? So these are probably going to be towards the bottom end. So let me just write them all out. So first we have the square root of 4, right? So I'm going to type that in the calculator. Actually, I don't need to. We all know the square root of 4 is 2 because 2 times 2 is 4. 0.4 is just 0.4. That's like having 40 cents. So we have $2, we have 40 cents. So far, $2 is much bigger. We have negative 2/3, so I'm going to type that in the calculator, know what that is. So negative 2/3, it's like having negative 66 cents. I'll round, I'll say 67 cents. Right, that's not so good. That's not so bad. Then we have the square root. Whoops, running out of space. The square root of 2. guys can see the calculator. The square root of 2. Alright, it's going to be basically $1.41. And then lastly, negative 1.5 is negative 1.5. So, if you look at the number, if I were to draw a number line, right, zeros over here, we have positive numbers over here, and we have negative numbers over here. Whoops. Right? The more negative, the smaller I'm getting. The more positive, the higher I'm going. Right? So the more positive, the bigger. The more negative, the smaller. So looking at it, this is the most. This here is the most negative number. Right? This would be somewhere over here. Let me get a different color. So that's going to be the smallest. So already, it's either going to be choice B or D. I can cross out choice D, choice A. I'm left with two choices. And then I have this other negative number, negative 2/3. So, looks like choice C is the answer. Because negative 2/3 is going to be between negative 66 cents. It's going to be somewhere around here. If I want to keep on going, I can keep on going. Okay, I've already graphed this one. I graphed this one. Now we have positive numbers. So now we have $2.40 and $1.41. I'm going to graph 40 cents. So 0.4 is between $0 and 1 cent. This is $1.41. So that's about here. Square root of 2. And this is $2. I've graphed them all, and I still match up with choice C. That's my answer. Alright guys, video's gone too long. Talk to you guys later. This will be your homework for tonight, homework number 7. Well, homework for tomorrow night at least. And take care. Have your question and summary ready for me to go. I'm expecting a couple good hot questions. Bye.